Hello, all the learners in Udemy. Thank you for enrolling in SPOTO Learning's course. If you want to get a free study material package, including CCIE workbook demo and study plan, or join the study group, you can find us on your Skype by searching SPOTO Learning or at +1 647 375 8952 on your WhatsApp. Also, if you have any questions, please feel free to contact us.
Hello everyone, welcome back. Today we are going to talk about SD-WAN and Cisco SD-WAN solution. To study this module, you would need a powerful computer, either a laptop or a desktop, to have at least about 16 GB memory. Or if you have a server available, that would be preferred. The reason of this is the lab of SD-WAN can be fully virtualized. Let me show you here. About this part, the vManage, vSmart, and vEdge, they are the controllers. These three parts can be fully virtualized in your own lab, and it's free of charge. You can download them from Cisco. The only prerequisite is you need enough memory and CPU power to power them up. For the vEdge over here, the virtual router, they are not free. They need a license. If you are willing to, you can purchase this from Cisco. Alternatively, SPOTO has a staged lab for students to use. You can have a chat with tutor and they will arrange this for you, I believe so. So it's up to you. In my own experience, when I was preparing for my first CCIE certification lab exam, I purchased a powerful workstation with about 32 GB memory. And I used that one, virtualized my lab. For my first CCIE certification, the service provider, my laptop was broken. And I don't have enough hardware to do the replacement testing. So to save the time, I rented a server for about 2 months. It's really up to you to use the lab of SPOTO, or you purchase your own hardware or rent something for yourself. In this class, we will be discussing what is SD-WAN and Cisco SD-WAN architecture. Within that architecture, we are going to explore vBound, vSmart, vEdge, and vManage, these 4 plans. What is SDN? SDN is software-defined networking. It is a network architecture approach that enables the network to be intelligently and centrally controlled using software applications. Network admins can manage the entire network, regardless of the underlying network technology. SDN also lets you design, build, and manage networks, separating the control and forwarding planes. As a result, the control plane is directly programmable and abstracts the underlying infrastructure for applications and network services. SD-WAN is one type of the SDN. They have similarity. They both have a controller, the centralized management. For example, in SD Access, it has DNA Center as the centralized management. Separation of forwarding and control. They have two different layers. Control plane is responsible for how the system operates. Forwarding plane is responsible for that forwarding. The third one is programmable. As the name says, software-defined, it needs to be programmable. These are three criteria of SDN. What kind of network is SD-WAN? It is not difficult to understand. For the LAN access solution, to collaborate with access layer, distribution layer, and core layer as the underlay, then provision the overlay, it is SD-access solution. SD-access is for the LAN side. For the WAN side, the solution is SD-WAN, which is similar idea as SD-access at some stage. You might be wondering why we need SD-WAN. What is the difference between SD-WAN and DMVPN, for example? SD-WAN is basically the smarter version of DMVPN. SD-WAN is very useful for retail business, where it has amount of cookie-cut stores. If we keep using traditional DMVPN solution, we will face today's WAN challenges. The first one, for example, is poor user experience. When the business opens a new retail store, provision the store network needs manual command line deployment. To initiate the network hardware, upgrade the network device software, DMVPN configuration is based on command line, which takes time for rollout and testing, lacking end-to-end network performance visibility. The second one is complex to operate. Of course, we can configure the DMVPN based on command line template, but it is quite hard to eliminate human error in this process. Imagine to support customer like KFC or McDonald's day and night, thousands of retail stores in a country. Maintain DMVPN in such scale is not an efficient way. It's also difficult to secure the WAN solution. DMVPN uses pre-share key for the IPsec tunnel. Usually, all spokes use the same pre-share key with the hub to communicate with the hub. If we lose one spoke, you are not going to change the pre-share key manually for all of this spoke, right? Otherwise, it will be a nightmare. You need to change the configuration for every single spoke. Of course, you might be arguing that we can use certificate, but the certificate is not automatic. It's manual. It needs to be populated manually. Imagine you have so many stores and do this one by one. This is very labor intensive, and you might well occur some human error as well. And why we move to SD-WAN? For technical, strategic reasons, it increases productivity, reduce costs, and transform the customer experience. It also reduces inefficiency of higher latency, heavy data center load, and a single point of failure. For the economical reason, it provides better management, costs, and uptime. Standardize the management of the services provided by the network. Location becomes transparent since geolocation becomes irrelevant. Management of a variety of connection types gets much easier. Bandwidth allocation management allows better service provisioning. In the traditional WAN solution, all user traffic is aggregated through the MPLS from the branches to the data center. Then from the data center, it heads out to the public internet to access the public cloud or access SaaS. In SD-WAN solution, the applications and the services become a flat surface, like the diagram shows here. Traffic from the branch is split at one edge, like internet local breakout, to the SaaS, to the data center. The traffic forwarding is more efficient, right? The forwarding decision is made by this one edge. They no longer need like the traditional WAN. It has to be aggregated towards the data center as use the single exit to access the public. This is more efficient and smarter. For the internet access design models, usually we have 4 types. For small business, for example, a remote branch has about 5 people, let's say. We can use this single router hybrid design model. A single router at the internet edge. We can have both MPLS, it is for the WAN connection, and the local internet breakout. We can leverage these 2 circuits to split the traffic based on the design. But the problem is, this router in the middle, it's a single point of failure. Although we have the redundancy from the network, we have both parts, 2 circuits. But this physical box over here is still a single point of failure. You lose this box, you lose everything. However, this design is for small remote branch, about 5 people, as we said. Most of the time, these people, this type of branch, they can afford downtime. If this hardware is broken, we just ship another hardware, wait for about 1 to 2 days, and the network will be back to normal. As an improved version, we can use dual router hybrid design model. They still have 2 circuits, one MPLS for the WAN, the other is for internet, for local internet breakout. The difference is, instead of use one hardware router, we can use 2 routers. Router 1 as primary and router 2 as secondary, and vice versa. We can split the traffic. We run VRRP in the middle. Also, we can run BGP for the traffic engineering to influence the traffic, which traffic, how it goes through the MPLS or go through the internet. From the LAN side, the traffic can point to this VRRP virtual IP address. If one failed, the VRRP, the second one will take over and the traffic will flow through this one. This is the basic idea, the common approach in this type of scenario. Nowadays, because of the cost of internet circuits, they become faster and faster and the cost reduced significantly, especially with the fiber access. So with this DMVPN IPsec tunnel or with SD-WAN solution, it's not necessary to have a dedicated MPLS circuit anymore. We can run this type of VPN tunnel through the public internet to simulate the MPLS circuit That's why in this design, we can have single router, dual internet design model. Have two internet circuits, one from ISP-A, the other from ISP-B for diversity and resiliency. For small office, we can still use one single box, right? If it's failed, it's failed. And we send the hardware, ship it over there, wait 2 to 3 days, and bring this online. For the improved version, like the diagram as above, we can use dual router, dual internet design model. We run IPsec tunnel, for example, DMVPN or SD-WAN through these two public internet service provider A and service provider B. Running BGP on top of that for DMVPN, or let the SD-WAN to handle this intelligently. At the LAN side, we can run VRRP as well to influence the traffic. If one failed, the other will take over and the traffic still flows. This is the idea about internet access design model. So you can have a think about which type fits your scenario. Hope this helps. This is the reason why we use SD-WAN instead of MPLS. The first is spending reduction, right? As we mentioned, MPLS circuits is more expensive than the public internet circuits. Usually, like MPLS circuits will cost at least several $100s, about maybe 20 megabit or 50 megabit bandwidth. For the internet circuits, about $100 per month, you can have 100 megabit bandwidth. So one is the cost. The second is the bandwidth. Use the internet circuits nowadays is much faster than the MPLS circuits. Categorizing traffic by function and type, sending backup traffic over the internet under an SLA. This is a common practice. During the off-peak hours, just send the backup data through encrypted tunnel like IPsec tunnel through the high bandwidth internet circuit, and running the business critical application through the dedicated MPLS. But nowadays, the internet is as fast as the MPLS, and it's stable as well. Elimination of bandwidth bottleneck caused by MPLS circuits. As we mentioned, internet circuits, they are fast and faster, cheaper and cheaper. Software updates, replication from hours to minutes. Of course, with the significant bandwidth bump up, you can replicate large significant amount of data through the public internet from hours to minutes. New internet-based services roll out from month to immediately, like the public cloud, software as a services. As long as you have public internet access, you have everything, right? So that's why the MPLS, these services, they are started to fade out. Everybody is moving towards the public internet circuits like SD-WAN or public cloud. This is the technical trend. Why use Cisco SD-WAN? So what SD-WAN will become? SD-WAN enables the interaction of the technologies hosted in SDN architectures, resolves the lack of on-site personal challenges. In traditional network, you need experts or at least the person with technical experience or knowledge to be on-site for the maintenance, troubleshooting, or implementation. With SD-WAN, it has ZTP, zero touch provisioning. Literally, it's you just deliver a box on site and plug the power it up with a network connection on the WAN port or the internet port. It will call to home for the authentication and grab the configuration, provision itself automatically. It's plug and play. So we no longer need on-site person with technical knowledge. As long as they can recognize the power cable, the network cable over the phone call, and they can deliver this for you. Network security and reliability are centrally managed in a unified management plan. SD-WAN is a foundation for emerging technologies that demand a reliable connection, such as IoT and big data. This is the future of SD-WAN and what SD-WAN will become. For Cisco's SD-WAN, as the diagram shows here, in 2018, this year, the market share of SD-WAN is about 46%. It's almost half of the market share. So Cisco is a top vendor, top player in this playground. The second one is VMware. It has 8.8% market share. The third one is Silver Peak. The market share is 7.4%. You can see the distance between these. They are huge. Cisco is absolutely the market leader for this technology on the market. So Cisco's SD-WAN, it is developed by a company called Viptela, which was founded by the former Cisco employees. And Cisco completed its acquisition of Viptela on August the 1st of August 2017. In June of 2018, Cisco had over 800 customers worldwide for the SD-WAN. In August of 2018, Cisco upgraded ASR and ISR images to run SD-WAN in iOS XE. This allowed its native Cisco device to run SD-WAN. These are the global enterprise customers who are using Cisco SD-WAN solution. You can see these customers, they have finance services, healthcare, pharmacy, manufacturing, retail, technology company, and also includes other industries. So basically, as far as I can tell, nobody was fired because of using Cisco solution. And as Cisco is the market leader in this area, that's probably everybody follows Cisco's step. So Cisco SD-WAN's benefits. This is the information from Cisco explains Cisco SD-WAN benefits. This just emphasizes why use Cisco SD-WAN solution. Like the first reason over here is secure automated WAN. Secure and automated, which means simple and secure. Application performance optimization. So application performance is optimized and guaranteed. Secure and direct internet access, DIA. Internet access no longer needs to go through the WAN connection back to the data center. Apparently, the technology trend is internet local breakout. Especially the public cloud becomes more and more popular. As long as you have internet access, you have everything you need, right? Branch multi-cloud access. With the internet local breakout design, you can have multi-cloud access directly from your local branch. No need to route the branch office traffic back to the data center, then go out to the cloud. This improves the access speed and traffic efficiency. Once again, with the internet local breakout design, the branch office could access the closest cloud infrastructure in its region. If the branch is in the UK, for example, then just access the cloud entrance in the UK instead of the United States. If the branch office is in Australia, you can access the cloud entrance in Australia, for example, Sydney. It would be much faster than traveling through half of the world, right, to find the entrance at the other side of the world. Just use your local region, the local entrance in your local region. So apparently, this will reduce cost. Maybe not reduce the CapEx cost, but definitely could reduce OpEx cost and the costs of time. The technology is called, there is a technology called ZTP. Cisco calls this ZTP. Zero touch provisioning, right? In traditional network, you need prepare the hardware. If you are going to bring up a network, for example, for a remote office, you need prepare the hardware, stage the hardware, initialize it, upgrade the software, copy-paste the configuration in the device and doing the test. Ship this device on-site, have a technical person to bring this online and doing the test to validate the deployment. With Cisco ZTP, you just ship a brand new device, ask the vendor or the reseller to ship this device directly to the site, on-site, where the location you are after. Plug in the power with the non-technical people, plug in the power, plug in the internet access connection, and it will call home, authenticate itself, grab the configuration, and provision itself fully automatically. This definitely saves times and labor. End-to-end security. The communication between the vEdge and between vEdge and data center through public internet are all encrypted. The entire process is automatic, right? Application experience. Intelligent multipath selection to use the fast circuit to reach the destination you are after. It's definitely speed up the application and improve the user experience. Cloud ready. Of course, vEdge router is available in the public cloud vendors. For example, Microsoft Azure and Amazon AWS. It's click and play, fast provisioning, and pay as you go. Simplicity and ZTP, as we mentioned, it's just easy and automatic, right? Trouble-free. Then let's dive into more details about Cisco SD-WAN architecture. SD-WAN solution, you can see there are 4 plans. The orchestration plan assists in the onboarding of the SD-WAN routers into the SD-WAN overlay. It's the job of vBound. There is a component called vBound. The job of vBound is to direct the vEdge to find the right vSmart. This solution can be designed and deployed to support multi-tenant. When the vEdge is onboarding, it needs to know who is the right vSmart it should talk to. In this case, it is the vBound first to talk to vBound, and you will get the right information you are after. The second one is management. The management plan is responsible for central configuration and monitoring. It is vManage. vManage is the component here in this slide. It can be multi-tenant or dedicated. The third one is the control plane. The control plane builds and maintains the network topology and makes decisions on where traffic flows. It is called vSmart. vSmart. It can be deployed as a container or a virtual machine. The last one is dart plane. The dart plane is responsible for forwarding packets based on decisions from the control plane. The vEdge, it can be deployed by physical or VirtualBox. This is Cisco's SD-WAN architecture overview. But please be aware that this is a solution developed by viptela, in fact. That's why when you download the VM image from Cisco website, you will notice that the keyword viptela appears frequently. So don't be surprised, because it is a viptela solution essentially. Cisco vBound orchestrator is a multi-tenant element of the Cisco SD-WAN fabric. It facilitates the mutual discovery of the control and management elements of the fabric by leveraging a zero-trust certificate-based whitelist model. So it's a single point of authentication, and it's whitelist model. So the vEdge you are going to bring on board needs to be whitelisted in advance. It automatically distributes list of vSmart controllers and the vManage system to the vEdge routers during the bring-up process. For situations where vSmart controllers, vManage systems, or vEdge routers themselves and behind net, vBound orchestrator facilitates the function of net traversal by allowing learning public and private IP addresses. The discovery of public and private IP addresses allow establishing connectivity across public and private WAN transports. vBound orchestrator itself should reside in the public IP space or reside on the private IP space with one-to-one net. We will explain more details about the net in the next slide. Just remember, vBound requires public IP address or a private IP address, but with one-to-one net to the public IP address. When delivered as a cloud service, the smart controllers are redundantly hosted in Viptela Cloud. When deployed as an on-premise solution by the customer, it is responsibility of the customer to provide adequate infrastructure resiliency. So, in summary, Cisco vBound main features are orchestrates connectivity and management plan. First point of authentication use whitelist model. Facilitates net traversal. Distributes list of vSmart vManage to all edge routers. Requires public IP address. Could sit behind one-to-one net. When you are trying to download vBound from Cisco website, you might not be able to find it because vBound image is the same as vEdge. It is just a vEdge running vBound feature. So just pay attention. It is a vEdge router image. For the net types, there are four of them. The first one is full con net. It's so an external host can send packet to internal address and port by sending packet to external address and port once the mapping has been created. Like the diagram shows here, when the vEdge would like to talk to this vBound, go through a full con net over here. And the vBound responded back to the initiator, communication initiator. The net session has been established at this stage. Then these two devices, they can talk to each other. No problem at all. This is called full con net. The second one is restricted con net. It's any external host can send packet to internal IP address if the internal device initiates a connection to the external host using previously created address mapping. So when this device would like to talk to this device, right? And this device responded back. The net session has been created. The address mapping has been created. Then the other side, the external device is not able to talk to the internal directly unless the internal device initiates the conversation first. Then it will receive the reply. The reply will be allowed. This is like the stateful firewall inspection. This is called restricted con net. The third one is port restricted con net, similar to address restricted con net with ports added to the mapping. When the mapping conversation started, it has a specific port. Only the conversation with this port attached, the conversation will be allowed. Otherwise, it is denied. This is port restricted con net. The last one is symmetric net. It requests from the same internal IP address and port to a specific destination IP address and port is mapped to a unique external source IP address and port. Only an external host that receives a packet from an internal host can send the packet back, right? as you see here, the net session has been established. Then the communication started with a specific port. Only the communication matches this port is allowed, otherwise it's denied. This is a symmetric net. Net traversal best practices. As you can see in this table, if we have public IP address at side A and public IP address at side B, it's trouble-free. This is mostly encountered, and the IPsec tunnel status is green or good. Or at side A and side B, they both use full connet. This is trouble-free as well. Right? Or like this. One side is full con, the other side is port address restricted. Or both sides, they use port address restricted. IPsec tunnel, no problem at all. So, as you can see, as long as you have public or full con, they're all good, right? Just don't use these two. The IPsec tunnel, they won't work. So have a look. So just be aware, as long as you have public full con, you should be all good. Cisco vSmart controllers are a scale-out control plane functions of the Cisco SD-WAN fabric. vSmart controllers facilitate fabric discovery by running the overlay management protocol, the OMP, between themselves and the vEdge routers. Together with vEdge routers, vSmart controllers act as a distribution system for the pertinent information required to establish the data plane connectivity directly between the vEdge routers. This information includes service-side, LAN, reachability, transport, the WAN-side IP addressing, IPsec encryption keys, site identifier, and so on. vSmart controllers also distribute data plane and application-aware routing policies to the vEdge routers for enforcement. Control policies acting on the control plane information are locally enforced on the vSmart controllers. These control plane policies can implement service chaining, various types of technologies, and generally influence the flow of traffic across the fabric. The use of centralized control plane dramatically reduces the control plane load traditionally associated with building large-scale IPsec network, solving the N²2 complexity problem. The vSmart controller's deployment model does not only solve the horizontal scale issue, but also provides high availability and resiliency. vSmart controllers are often time-deployed in geographically dispensed data centers to even further reduce the likelihood of control plane failure. When delivered as a cloud service, vSmart controllers are redundantly hosted in Viptela Cloud. When deployed as an on-premise solution by the customer, it is the responsibility of the customer to provide adequate infrastructure resiliency. Cisco vManage provides single pane of glass for day 0, day 1, and day 2 operations. Its multi-tenant web-scale architecture caters to the needs of the enterprises and the service providers alike. Some of its key functions include centralized provisioning, centralized policies and device configuration templates, ability to troubleshoot and monitor the entire environment and performance, perform centralized software upgrades on all the fabric elements. vManage GUI allows segregated administrative access by implementing RBAC for proper roles and responsibilities. Its programmatic interface enables DevOps operations. These interfaces can also be used to extract performance statistics collected from the entire fabric. Performance statistics can be exported into external systems or to Cisco vAnalytics tool for further processing and deeper insight. We have discussed 3 components: vManage, vSmart, and vBound. These 3 components are controllers of SD-WAN solution. 3 of them can be deployed in Cisco Cloud Ops and managed by Cisco Cloud Ops. You can consume these as a service, or they can be deployed and maintained by MSP, Managed Service Provider of Cisco, and you consume them as a service as well in the MSP cloud or in the Cisco cloud. The third option is the customer to host the controllers by themselves as on-premise or in the private cloud. These are 3 models you can think about, right? As long as they meet your business requirement, just pick one of them or 2 of them. The controller deployment, you can deploy them on-premise or hosted in the public cloud. For the on-premise, it is supported by VMware, vSphere, ESXi, or KVM. These components can be deployed as a VM, virtual machine, or container. It's same as the public cloud solution, Amazon AWS or Microsoft Azure. These components can be deployed as VM or container as well. So it's similar, just different location. One is on-premise, the other is hosted. Once again, it really depends on your requirement and business need. Pick up the one suits you better. It's not about right or wrong, just about good and better, whichever suits you. Controller scaling. For vManage, validated scale is 2,000 devices per single instance. Maximum production deployment is 6 vManage instances per cluster. For the vSmart, validated scale is 5,400 connections per single vSmart. Max production deployment, 20 vSmarts instance per cluster. For the vBound, validated scale is 1,500 connections per single vBound. Maximum production deployment, 6 vBounds instance per cluster. So keep in mind, These are the controller scaling validated and recommended by Cisco. Just follow the Cisco best practices. Cisco vEdge, this is a data plane. We have discussed the control plane and controllers. This is the data plane. It's Cisco vEdge. Cisco vEdge routers are the data plane elements of the Cisco SD-WAN fabric. They are, in essence, WAN edge routers, positioned everywhere SD-WAN fabric needs to be extended to. vEdge routers are responsible for encrypting and decrypting application traffic between the sites. As mentioned earlier, vEdge routers establish control plane relationship with vSmart controller to exchange pertinent information required to establish the fabric and learn centrally provisioned policies. Data plane and application-aware routing policies are implemented on the vEdge router. vEdge routers export performance statistics as well as alerts and events to centralized vManage system for a single panel of glass operations. vEdge routers also leverage standard-based OSPF and BGP routing protocols for learning reachability information from service-side interfaces and for brownfield integration with non-SD-WAN sites. vEdge routers have very mature full-stack routing implementation, which accommodates simple, moderate, and complex routed environments. For Layer 2 redundant services, or vEdge routers implement VRRP first hop redundancy protocol, which can operate on a per VLAN basis. vEdge routers can be brought online in a full zero-touch deployment fashion or by requiring administrative approval. Zero-touch deployment relies on the use of signed certificates installed in the onboard tamper-proof module, the TPM, to establish unique router identity. vEdge routers are delivered in both physical or virtual form facts. Physical form facts are deployed as appliances with either 100 megabit, 1 gigabit, or 10 gigabit based on the throughput needs. The virtual form fact can be deployed in public clouds such as AWS and Microsoft Azure, or as an NFV on the vCPE, UCPE platforms, leveraging KVM or ESXi hypervisors. In summary, Cisco vEdge Cloud Router is a virtualized version of the vEdge router, inheriting all the capabilities offered on Viptela's physical branch routers. vEdge Cloud can be installed as a virtual machine on a KVM hypervisor or as a VM on a VMware ESXi hypervisor, as well as in public cloud environments such as Amazon AWS or Google Cloud Platform. vEdge Cloud can be used as a virtual network function, VNF, for a virtual CPE deployment at the branch. It can also be used as a virtual private cloud, VPC gateway, for customers that have a workload residing in Amazon AWS. vEdge Cloud deployment methodology. It can be on-premise, use ESXi, VMware, or KVM, running on a physical server, or just host them directly in the public cloud. Pick up whichever methodology meets your business requirement. There are other two components. One of them is vAnalytics. This is like the diagram the slide shows here, this component. This is a cloud-based analytic engine. It's an optional solution element. It's not compulsory, it's optional. But it's highly recommended to install this, and you can have a play with it. Basically, it's an analytic engine. It collects the fabric telemetry and doing the capacity projections. It's like based on the historical data doing the forecast, and monitor the SLA violation trends, utilization, and if anything abnormal, it will alert the administrator. Also shows like the application QoE, functions as at carrier grading. So you can have installed this in the lab and have a play with. It's an analytic engine, optional. The other component is the API, a third-party API. This one I will show you in the slide over here. You can see one is SD access, the other is SD-WAN, right? So when the user in the SD access routes the traffic here, then how does it go through to the SD-WAN side? It's the boundary over here, right? One is SD access, the other is SD-WAN. The answer is this third-party API. This one, third-party API, will have the communication to the DNA center. So they talk to each other to tell the traffic how to go through to access each other. Right now, this API solution is not mature. It's like the first version still in like, it's very light. The functionality is very light. So we reasonably believe in the first version of the lab exam, this won't be tested, right? But in the third or the second or the third generation of the lab exam, Cisco might include this into the exam. It depends on the progress of the developing of this API. So just to let you to be aware of this. Right now, the functionality is very light. You even can't test this a lot in the lab. It really depends on the progress of Cisco's development speed. So don't worry about too much. Just have a look about this slide. Understand the third-party API, and while doing the communication between the vManage to the DNA center. That's all for right now. So after we have discussed these components for the SD-WAN solution, the overview over here is for the network engineer or administrator, the vManage over here, this is the user interface, the graphic user interface. The policies, configuration, authentication, They are all stored here, right through the GUI. And when the vEdge is onboarding, it talks to the vBound first. Then the vBound, vManage, and vSmart. These three, it's like a triangle of the controllers. vBound will tell the vEdge router who is the right vManage you should talk to, and who is the right vSmart controller you need to talk to. And after that, the vEdge router, it talks to the vManage and the vSmart controller. Then this is the control plane, right? Then the vEdge routers, they will form the data plane based on the instruction received by the vManage and the vSmart. This is at the high level how this solution works. The SD-WAN platforms, deploying branches and remote locations is not always a one-size-fits-all, especially when it comes to the cloud. Depending on your needs and the use case will determine which type of platform you need at your remote location. Regardless of the platform you need, they all work together seamlessly and can be managed through a single user interface. Like over here, there are 4 types of the platforms you can use. One is branch virtualization. They use ENCS. ENCS is Optimized Enterprise NFV. NFV stands for Network Functionality Virtualization. So it's Optimized Enterprise NFV platform. The Cisco ENCS is a hybrid platform that combines the functionality of a traditional router and a traditional server with a smaller infrastructure footprint. These two models, right? 5100 and 5400, they are both router and server. The second option is public cloud. You just host them directly in the public cloud, either Microsoft Azure or Amazon Web Services. In the near future, Google Cloud will be supported as well. So you can have 3 options for the public cloud. The third one is SD-WAN, hardware appliance. This is Viptela. This is Viptela hardware. It has vEdge 100, vEdge 1000, vEdge 2000s. They are just different throughput. Similar software functionality, but you see different hardware throughput. The last one is branch services hardware appliances. This is the genuine Cisco product line, like ISR 1000, ISR 4000, and ASR 1000. SD-WAN is natively integrated in the ISO-XC software image. As it shows here, it's more about different throughput. So, as we just said, regardless of the platform you need, they all work together seamlessly and can be managed through a single user interface. It really depends on your business requirement. Pick up whichever fits your need. The SD-WAN pricing model. The pricing model consists of 2 components. One is the subscription license. The subscription license is for the software charged. It's charged per CPE. You can purchase 1 year, 3 year, or 5 year. This cost is dependent on 2 facts: service bandwidth and features. The second cost, this is the subscription. The second cost is it's a permanent cost, perpetual cost of the Viptela CPU hardware. So this is the total operational cost of the Viptela solution. Viptela hardware platform, as we mentioned, they have different hardware models with different performance. It's more about the throughput and the ports. So this is just information for your reference, right? This is a Viptela solution. Also, this is the V8 router continued. This is 100 series. This is 100 wide network only. They have antennas with 3G, 4G LTE and GPS. They all have GPS. Just the information for your reference. That's all for today. So hope you enjoyed this lesson. Thanks for watching. See you in the next class.